Today, we're going to get right to the heart of artificial intelligence. We're going to tackle a huge question. How does a machine actually learn anything? And to do it, we're going to look at a super simple algorithm from way back in the 1950s that, believe it or not, is the granddaddy of all the AI that's changing our world today.
Seriously, have you ever stopped to think about it? We hear that AI is learning from data all the time. But what is that? Is it just memorizing things? Is it some kind of weird digital magic? How does a piece of code go from knowing absolutely nothing to making predictions that are actually correct?
Well, the answer is surprisingly simple, and actually it's kind of human. When you boil it all down, machine learning is about making a guess, checking if you got it right or wrong, and this is the key part. If you got it wrong, you make a tiny adjustment so you're a little bit smarter next time. That's it. It's all about learning from your errors. So to really get this, we've got to meet the hero of our story today, the perceptron. Now, just think of it as a single artificial neuron. It's the most basic building block for those massive neural networks that power all modern AI. And it really only does three simple things. It takes in some information, it makes a decision, and then it learns from that decision.
So the real secret sauce for the perceptron is these little internal knobs it can turn. We call them weights and a bias. It basically uses these to decide how important each bit of information is. And the learning rule we're going to see is just the instruction manual for how to tweak those knobs every single time it gets an answer wrong.
All right, so to see how this thing actually works, we're going to give our perceptron a classic first test. It has to learn a simple logic puzzle called an AND gate. The rules are super straightforward for a person, but can a machine figure them out all by itself, just by trial and error? Let's see.
Okay, so the rules of this puzzle are really simple. The only way you get a 1 as the correct answer is if both input 1 and input 2 are also 1. If that's not the case, the answer is always -1. Now, our perceptron starts out knowing none of this. Its only job is to look at these 4 examples, one by one, and figure out the pattern all on its own.
And this right here, this is the golden rule of this whole process. It's so important. If the perceptron makes a guess and it's correct, it does absolutely nothing. It doesn't change a thing. It only learns, it only adjusts those internal knobs when it makes a mistake. If there's no error, there's no learning. Simple as that.
Okay, so how does it actually do the learning part? Well, it uses this simple little formula you see here. And don't worry, it's not as scary as it looks. All it really says is the new weight is going to be the old weight plus a small correction. And that correction is determined by the input it just saw and, you guessed it, the mistake it just made. It's basically a mathematical recipe for nudging itself in the right direction for next time. All right, theory time is over. Let's put our perceptron to the test. We're going to start its training. This is its first pass through all the data, what we call iteration 1. Let's show it the 4 examples from our puzzle and just see what happens.
So right at the start, our perceptron is a total blank slate. I mean, it knows literally nothing. All its internal settings, its weights, its bias, they're all just 0. It has no opinions, no knowledge. It's starting from scratch.
Okay, first up, we show it our first example from the puzzle. Inputs of -1 and -1. Since all its weights are 0, it just multiplies the inputs by 0, adds the bias of 0, and its prediction, a big fat 0.
And, whoops, right out of the gate, we've got a mistake. Its prediction was 0, but the correct answer, the target, is supposed to be -1, so it's wrong. And what was our golden rule? A mistake means it's time to learn.
And this is the magic moment. This is where the learning happens. It uses that update formula we saw. So the new weight, W1, is the old one, 0, plus a correction that's based on the input, -1, and the target, -1, which comes out to 1. Same thing for W2. And the bias gets adjusted too. And just like that, its internal knobs are no longer set to 0.
And there we have it. After seeing one example and making one mistake, our perceptron's brain isn't empty anymore. It has its very first thought, its first piece of knowledge learned directly from its own error.
So, now what happens for the rest of this first pass? Well, check this out. After that one single mistake, its new weights are now 1, 1, -1. And it uses these new weights on the next 3 examples. And it gets every single one of them right. And since it didn't make any more mistakes, it doesn't do any more learning in this round.
Okay, so it got through the whole list once, but is it actually smart now? Has it really learned the rule? The only way to know for sure is to test it all over again, from the very beginning, using the knowledge it just gained. So let's start iteration number 2.
This is it, the moment of truth. Using those weights it learned, 1, 1,
-1, we show it all 4 puzzles again. First case, it gets it right. Second case, correct again. Third one, yep, nailed it. And the last one, perfect. It got every single prediction right this time. No mistakes at all.
And there you have it. It did it. All it took was making one little mistake and adjusting itself just that one time. Because it made no mistakes on this second pass, its learning is officially complete. It has successfully figured out the logic of the AND gate.
And that number, 2, that's how many iterations or passes through the data it took. That's all. One pass to make a mistake and learn, and a second pass to prove that it had learned the lesson perfectly.
So, you might be thinking, okay, that's a neat little logic puzzle from the 1950s. Why does this matter today? Well, because this super basic idea, this is one of the most powerful concepts in all of modern tech. This tiny seed is what grew into the entire forest of AI that we see all around us.
And here's the kicker. Those giant neural networks we hear about all the time, the ones that recommend movies, translate languages, or generate incredible images, they're all built on this exact same principle. They're just made of millions, sometimes billions of these simple little units, all learning from their mistakes together on a massive scale.
Just look at how this thing has evolved. It's pretty wild. Back in the 50s, a single perceptron learned a simple logic puzzle. Fast forward a few decades, and networks of them could learn to see a cat in a photo. And now, today, these same core ideas allow huge networks to understand and even generate human language, art, and code.
So that kind of leaves us with this one big, final thought, right? We just watched a machine learn fundamental logic from absolutely nothing. All it used was a simple rule for correcting its own mistakes. And if that's what's possible with just one artificial neuron and one simple rule, it really makes you wonder, what are the limits when you have a billion of them? What can't they learn?